Lesson 7.4, Evaluate Logarithms and Graphing Logarithmic Functions. We're going to take the exponential functions that we've been working with in the last few lessons and find the equation for their inverses. Let's start. It says graph y equals 3 to the x and its inverse. When we think about graphing inverses, that should bring you back to a chapter, like a couple of chapters ago, when we sketched the reflection over the line y equals x. So that means we have 0, 0, 1, 1, 2, 2, and so on, all the way up to the right, and all the way in the other direction, -1, -1, -2, -2, and so on. Go ahead and start, everyone, by connecting those dots to create the equation for y equals x, the reflecting line for inverse functions. Okay, once you have that, if we sketch the graph y equals 3 to the x, hopefully you remember how we did this. We just made a table. That's what I did in 7.1 and 7.2, and this is what we'll do now. The table is going to be beneficial not only for this nonlinear function, but also to sketch the graph of the inverse. If I pick values for x, we're going to determine what the y value equals. So let's go ahead and start with 0, right in the middle. 3 to the 0 power is 1, because anything to the 0 power is 1. As x gets bigger, watch how quickly the graph or the output gets bigger. If I pick 1 for x, 3 to the first power is 3. And if I pick 2, 3 squared goes all the way up to 9. So we're almost off of our graph already. If I go in the other direction and make x negative, the graph gets really small really fast. If I let x equal -1, 3 to the -1 power, you'd have to take the reciprocal of 3, and that would be 1/3. And if I go to -2, 3 to the -2 power would be 1 over 3 squared, which is 1/9. Gets even closer to that x-axis. Let's plot these 5 ordered pairs. We have 0, 1, we have 1, 3, we have 2, and it goes all the way up to 9 right there. So you can kind of see a little bit of that curve happening. On the left side, if we go to -1, we drop all the way down to 1/3. Oh, that's not even close, is it? 1/3. So a little bit lower down there. At -2, it's all the way at 1/9. Well, that's going to curve down low for us. Remember, when we have these exponential functions, we're going to have an asymptote right on the x-axis. So go ahead and draw a line as best you can, going right next to the x-axis on the left, and then curving up to the right. And when you're done, your graph should look something like this. Now for us to sketch the graph of the inverse, what I'm going to do is just take these values for x and y and flip them. So instead of 0, 1, I'm going to reverse that order 1, 0. Remember, reflecting over the line y equals x. 1, 3 will become 3, 1. 2, 9 becomes 9, 2. -1, 1/3 becomes 1/3, -1. That'll be interesting to plot. And then 1/9 goes to ninth. Well, that's a 9. Goes to -2. If we plot these points, 1, 0 over here on the right, 3, 1, and 9, 2, you can see it's going to get really close to the x, or on the right-hand side, it's going to go, I don't even know what I'm trying to say. Never mind. We'll keep going. 1/3 is just barely to the right, and we go down to -1. 1/9, we go down to -2. So we're actually getting really, really close to the y-axis this time. Watch what happens as I connect these dots. Now we're not going to cross over the y-axis at the bottom. So it gets really, 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 really close, and then all of a sudden it just turns to that right-hand side and goes off to infinity. There's the sketch for the inverse of our exponential function y equals 3 to the x power. Next, we're asked to determine the equation for the inverse. If you recall our steps from before when we had linear functions, our first step was to replace f of x with y. And that made that solving for y process go a little bit better. In this case, we already have y equals, so we're good to go on that first step. In the second step, we said switch x and y, just like we did with our ordered pairs. So switch x and y. If we do that for our new equation, we'll have x equals 3 to the y power. So here's where things get a little dicey in step 3. Solve for y. Well, if we look at where y is located, it's an exponent. It's not 3 being multiplied times y, but it's 3 to the y power. To get y by itself, we can't move the 3 over because the y is an exponent. It's not in the same level as 3. So this is where we get stuck. We can't actually solve for y when it's an exponent in an equation. Since we actually have an equation or a picture graphed for the function, we do need to come up with some type of equation. Therefore, the inverse of an exponential function is called a logarithmic function. Logarithmic, logarithmic function. It's actually the name given to specifically write the equation for the inverse of that exponential function. So as we look at kind of figuring out how this works, to write the inverse of any exponential function, just first thing I want you to do is just flip the order around. So I didn't actually change the equation from here to here. I just wrote it in reverse order. So I put the y on the right side, not the left side. Then we'll switch the x and the y just like we set up above. And then we're going to add a new kind of phrase to determine that step 3. To solve for y, we're going to loop the equation. We just say loop it, which I know sounds kind of weird to say, but this is going to be helpful. If y equals 3 to the x, if we just want to reverse the order around, we're just going to write 3 to the x equals y. If I switch x and y like we did before, this would be 3 to the y power equals x. So when we loop it, here's what I mean. To create that logarithmic function, we use the prefix log. So we're going to use that kind of this first part right here, and that's actually going to be written in the equation. So we're going to write log. The base for the exponential function, which is 3, is going to be the little base for our logarithmic function. And here's where the looping comes in. We're actually going to take from that 3, I'm going to loop it over to the right-hand side, and we're going to take log base 3 of x. And it has to equal something, so that's when you loop it back to the exponent, and you get y. So then to write your final answer, we'll put y first on the left-hand side because we always read from left to right. So we're going to say then y equals log base 3 of x. Notice 3 is a little subnumber. The y, the log prefix, and the x are all in the same row. So that may have been a little interesting to kind of try to process. So let's try to just do some rewriting from one form to the other. It says rewrite the equation in logarithmic form. So it doesn't say we're creating the inverse. We don't have to switch anything around first. We're just going to rewrite it in logarithmic form. When you're asked to do that, you're always going to start with the log prefix. So then remember, the base for your exponential function is the same as the base for your logarithm. That'll always be true. From here, we loop it. If it's log base 2, we'll take the logarithm of 8. And what should that answer equal? It should equal 3. And that's it. You're just converting from one form to the other. The next one, 4 to the 0 power equals 1. Well, we know that's true. In logarithmic form, we're going to start by saying log, base 4, because we want it to match, and then we loop it. Of 1 equals 0. You guys try that last one. See if you can rewrite that statement in logarithmic form. When you think you have it, press play, and then see if we get the same answer. Did you get log base 7 of 7 equals 1? If you did, then you've converted it correctly to logarithmic form. Now in the next row, we're going to go backwards. I've given you the equation in logarithmic form. We're going to write it in exponential form. When we do this, the log prefix is going to go away. And we're going to start with the base. If the log is base 3, then our exponential function also is base 3. Now when we loop it, the right-hand side is going to give us our exponent. So we're going to take 3 to the 4th power. What should that equal? It should equal 81. So yes or no, everybody? Is that a true statement? Does 3 to the 4th power equal 81? Yes, it does. In the next equation, if I cancel the log out, notice the base is missing. There isn't anything there. If the base is missing, that means it's automatically base 10. So if you're ever wondering what to do if the base isn't there, it defaults to base 10, and then we just go on from there. If we take 10 to the 3rd power, that should equal 1,000. And that last one, log base 1/2 of 32 equals -5. Here the base is a fraction. So I'm going to put the fraction vertical. I'm not going to do it like the diagonal fraction they wrote it out as. And I'm going to raise that to the -5 power. That should equal 32. So if we had a fraction with a negative exponent, we would take its reciprocal, which would be 2 over 1 to the +5 power. And that, in fact, does equal 32. You'll notice up above, all we did was convert forms. Right here, or right here. Now I'm going to show you what kind of values we could actually plug into our calculator and what kind of values we'll have to determine maybe using our power chart. There are 2 different types of logarithms, depending on if you have a base that's a number or a base that's e. So normal counting is base 10. Therefore, a common logarithm either defaults to base 10 or uses any other number as a base. And so we've seen both of those so far. The only thing we haven't seen yet is if we take the inverse of an exponential function where the base is e, like what we talked about in lesson 7.3. The inverse for base e equations is called natural logarithm. And it's not NL, it's actually LN, which I know seems kind of weird. So that's an L and then an N, but they use lowercase l. And you only use this ln as your conversion if your original base was e. Okay, so down below we've got 4 examples. It says log of 100. If I say what is the base, we just look for that little kind of sub number right here. And remember, if it isn't written there, the base is 10. But in the next example, it says log base 2 of 32. Now if I want to know what the base is, it's already given. The base is 2. We're not plugging anything into our calculators just yet. We're just kind of determining what things work and when they don't work. ln 12, notice there's that ln, that means natural logarithm. Automatically base e, so you never actually have to write the e in there because ln only works for base e, which then kind of makes this last problem goofy. It says ln base 3 of 5. If you have ln and they try to default at a number base, this is not possible. ln only works for base e, no number bases. We'll finish these notes in class tomorrow. Make sure you have a power chart and a calculator.